ሰላም ሰላም ወደ ማትስ አካዳሚ ቲዩብ ቤተሰቦች ወርክሺት 1 እና ወርክሺት 2 ከዚህ በፊት ሰርቼ ለቀቀላችኋለሁኝ ወርክሺት 1 ላይ 12ኛ ጥያቄን ዘልዬ ነበር 12ኛ ጥያቄ እና 10ኛ ጥያቄ ተመሳሳይ ስለመሰሉኝ 12ኛ ጥያቄ based on question number 10 ሰራላችሁ በሚል አልፌው ነበር አይ ሲሚላር አይደሉም ሰራለን ባላችሁኝ መሰረት ይሄው 12ኛውን ጥያቄ አሁን ሶልቭ ማድረግላችሁ ይሆናል number 12 let L1 is given by this parametric form and L2 is given here in parametric form these two lines are given based on this information we are asked these three issues ሶስት ነገሮች ተጠይቀናል the first thing we are asked to show L1 and L2 are skew lines and the second one we are asked to find two planes containing these two parallel planes containing these two lines the third one the distance between the two planes ተጠይቀናል so I will show you each of them separately okay the first part እንሄዳለን a ላይ ምንድነው ሚለን show that L1 and L2 are skew lines by definition skew lines are lines that will never intersect nor parallel okay parallel when intersecting lines ያልሆኑ ላይኖች ምን ይባላሉ parallelም intersect ማያደርጉም ላይኖች skew lines ይባላሉ so there is a condition for parallel lines there is a condition for intersecting lines there is also a condition for skew lines okay now I will tell you the condition for skew lines okay suppose we have L1 is given in parametric form L1 is x is equals to 3 minus t y is equals to 4 plus 4t and z is equals to 1 plus 2t this is L1 which is given in parametric form ይሄንን ወደ Cartesian form መቀየር ያስፈልጋል the Cartesian form for this is x y z is equals to 3 comma 4 comma 1 plus t into minus 1 comma 4 comma 2 ይሄን Cartesian form ከዚህ ነው የምናገኘው ከዚሁ ከፓራሜትሪክ ፎርም ነው 3 4 1 ን ለብቻ እዚህ ጋር እናወጣለን then የt coefficient minus 1 4 እና 2 እናስቀምጣለን this is Cartesian form so to make things easy ይሄንን እቺን x1 በሉልኝ y1 z1 this is a point on L1 and this is the direction vector the direction vector entryዎቹን እንደዚህ እንበላቸው a1 b1 c1 ብለን እንሰይማቸው so assume this point is or denote this point by p1 ይሄንን p1 ብለን represent እናድርገው ይሄን direction vectorአችንን ደግሞ የl1 ን v1 ብለን represent እናድርግ okay this is L1 now L2 is also given in parametric form the second line L2 is given in parametric form ይሄ L2 ምንድነው x is equals to s y is equals to 3 and z is equals to 2s ነው ተብለናል so we can change this into its equivalent form x y z የዚህ equivalent form ምንድነው የሚሆነው x ማለት s ነው ማለት 0 3 0 ይሆናል ለምን s ማለት 0 plus s ስለሆነ ኦኬ ይሄ ምንድነው 3 ማለት 3 plus 0s ነው ኦኬ then z ማለት 0 plus 2s ነው ኦኬ 0 3 0 ብዬ ጻፍኩት እዚህ ጋር ለዛ ነው plus s into እዚህ ጋር የs coefficient 1 ነው እዚህ ጋር 0 ነው እዚህ ጋር 2 ነው so 102 ይሆናል ማለት ነው 102 ምን አደረግን the second line equation of the second line in the Cartesian form ጻፍን. So to make things easy, say this is x2, y2, z2 በሉልኝ. And this direction vector for the second line a2, b2, c2 እንበለው. So shortly ይሄንን point capital P2 በሉልኝ. ይሄን direction vector ደግሞ v2 በሉልኝ. Now I will tell you the condition for skew lines. Now L1 and L2 and L2 are skew if this condition is satisfied. There are different conditions actually. ምን አይነት condition satisfy ሲደረግ ነው ይሄንን skew የምንለው? One of the condition may be P2 minus P1 dot you take the dot product of V1 and V2 and we calculate the dot product of P2 minus P1 with V1 cross V2. This should be non-zero, okay? ይሄ ከዜሮ የተለየ መሆን አለበት. The other thing or you can also use this condition. አንዱን condition ብቻ መጠቀም በቂ ነው. There must be a certain values x2 minus x1, y2 minus y1, z2 minus z1. The second entries a1, b1, c1, the second row, third row a2, b2, c2 ይሆናል. Okay, the determinant of this matrix should be different from the. So you can use one of these two conditions. Okay, የሚቀላችሁን የሚያጥረውን condition መጠቀም ትችላላችሁ. So for now I will take this condition. If this condition is satisfied, we say that L1 and L2 are skew lines እንላለን. So what is our determinant? The determinant x2 minus x1 ማለት 0 minus 3, which is minus 3. Okay, then y2 minus y1 means 3 minus 4, which is minus 1. And z2 minus z1 means minus 1. Okay, this is the first row. A1 is minus 1. B1 is 4. C1 is 2. A2 is 1, 0, 2. This is some kind of determinant of 3 by 3. So የዚህን determinant calculate አድርጉ. So the determinant of this matrix becomes minus 32, which is different from 0. If it is 0, the lines are not skew. ወይ parallel ናቸው ወይም intersecting lines ናቸው እንላለን ማለት ነው. Okay, so L1, since this number is different from 0, L1 and L2 are skew እንላለን. Okay, now in B part it says find two planes pi1 and pi2 such that pi1 is parallel to pi2. At the same time, pi1 contains L1 and pi2 contains L2. ምንድነው የተጠየቅነው? ሁለት ፕሌኖች pi1 እና pi2 parallel የሆኑ L1 እና L2 እነዚህን ሁለት ላይኖች የያዙ planes equation of planes ተጠይቀናል. Okay, so now here I will show you the solution for B part. Okay, ወደ B ስንሄድ there are principles that we need to know. These two lines L1 and L2 are skew. That means they are found in different planes. Those planes are in fact parallel. So we are going to calculate the two parallel planes containing this L1 and L2. L1 እና L2 የያዘ ሁለት parallel plane ተጠይቀናል. So the fact or the principle that you need to know here is any planes parallel to L1 has to have a normal vector which is perpendicular to V1. Okay. So we need this fact. Okay. We need this fact. Any plane parallel to L1 has to have a normal vector which is perpendicular to V1. Okay. Ziga V1 yalkuኝ represent ያደረኩት አለ V1 V2 መልሼ ጽፈዋለሁኝ. So this fact should be known. At the same time, similarly, we need to have this concept. Similarly, any plane parallel to L2 has to have a normal vector that is perpendicular to V2, because each planes have their own normal vector. So we need to have this principle. So a normal vector to our plane should be perpendicular to both V1 and V2. So a normal vector to our plane should be perpendicular to both V1 and V2, where these V1 and V2 are the direction vector for the two lines. Okay, just to remind you the Cartesian form of the two lines, L1 ብለን የጻፍነው. Okay, so here you can assume this as P1, this as P1, this V1, which is a direction vector for the line 1, and L2 is a line which is given as, okay, these are the two lines. So you can give a notation for this P2 and P2 below. P1 and P2 are the points on the lines, and say this is V2, which is assumed to be the direction vector for the line 2. Okay, so we can calculate the cross product of V1 and V2, okay, which is normal to the plane pi 1, at the same time which is also normal to the plane pi 2. So now we calculate the cross product of V1 and V2. Okay, V1 cross V2 will gives ijk. So therefore, the cross product of these two vector will gives us 8i plus 4j minus 4k. Don't forget to check my result. So this is the cross product of the direction vectors. So this vector will be a normal for both plane 1 and plane 2. So if we have the normal, the only thing that we need to determine the two plane is we need a certain point on the plane. Okay, so now take a certain point on L1. Say the point 3,4,1 is on L1. You can get this point by putting t is equals to 0. So the equation of the plane pi 1 will be 8 times x minus 3 plus 4 times y minus 4 minus 4 times z minus 1 is equals to 0. This will be the equation of the plane 1. Okay, the equation of the plane 1. By the way, to determine the equation of a plane, we need only a single point and the normal vector. So this will be the equation of the plane 1. Similarly, we can determine the equation of the plane 2 by taking a certain point on L2. So similarly, you can get the equation of the second plane. Similarly, you can get the equation of the second plane by taking a certain point on L2. Okay, For example, this point is 0, 3,0 is a point on L2. You can take this point. Already this point, this normal vector is a normal vector for both plane pi1 and pi2. So by using this point and the given normal vector, you can determine the second equation of the plane. Okay, so the last one is finding the distance between the two planes. Okay, so to find the distance between the two planes, we need to have the formula for this specific case. So in this particular example, we can use this formula to calculate the distance between the two planes. Okay, actually you can follow different ways, but this makes things short. So distance between the two planes will be calculated by the V1 cross V2. We take the cross product of the direction vectors for the line dot with P1, P2, where these P1, P2 are the points on L1 and L2 respectively. We take this thing in the absolute value over the magnitude of V1 cross V2. Okay, so to remind you what this V1, V2, P1, P2. So this P1 is the point that we have on L1. P1 is 3, 4, 1. P1 is 3, 4, 1. P2 is the point on L2, which is 0, 3, 0. 0, 3, 0. V1 is the point on, the direction vector of L1. V1 is -1, 4, 2. This is -1, 4, 2. And V2 is the direction vector for the second line, which is 1, 0, 2. Okay, we do have these things 1, 0, 2. So these are enough to calculate the distance between the two vectors. Now V1 cross V2 is already obtained. Okay, V1 cross V2 is already obtained as 8i plus 4j minus 4k. Okay, the cross product of the direction vector. This is V1 cross V2, 8i plus 4j minus 4k. We have this thing. So from this, we need to also calculate the magnitude of this V1, V2. The magnitude of this V1, V2 is in the radical 8 square plus 4 square plus negative 4 square, which is radical 96. Or you can rewrite this thing as radical 96 means 2 radical not 2. This is 4 radical 6. Okay, V1, the magnitude of V1 cross V2 is this one. Again, P1, P2 means P1, P2 means P1, P2 is P1, P2 means P2 minus P1. Okay, this is how much? Minus 3 minus 1 minus 1. Okay, you can take the difference between these two. So it gives this one. Now we can substitute all these values. So the distance between the two planes, D is equals to, in the absolute value, we take the dot product of these two vectors. So the dot product of 8, 4, minus 4 with minus 3, minus 1, minus 1 over the magnitude of V1 cross V2 is radical 96, which is 4 root 6. So this is the same as 8 times minus 3 is minus 24. 4 times minus 1 is minus 4. Minus 4 times minus 1 is positive 4. Okay, so over radical 4 radical 6, this means 24 over 4 radical 6, which is by 4, 6 by 4 root 6. The result is radical 6. Okay, so the distance between the two planes, is radical 6. This is the distance between the two planes.